Dear participants, we will begin the session soon.
So, am I audible?
Yeah, I think we can hear you well.
Thank you. Fine.
Good evening, sir. May we start the session?
Yeah, please start.
Ratnakishore, sir, am I audible to you?
Yes, you're audible, ma'am.
Okay. A very warm welcome to the day 2 of 6 days online faculty program on From Idea to Impact research paper writing, publication, and patent filing, organized by the Department of Electronics and Communication Engineering in association with R&D cell of Vidya Academy of Science and Technology, Technical Campus, Kilimanur. We are happy to have you all once again for today's invited session titled Advanced Scholarly Writing and Research Storytelling. This focuses on one of the most critical aspects of research, how to effectively structure, narrate, and communicate research ideas through high quality scholarly writing, thereby improving the clarity, impact, and publication potential of research work. It gives me immense pleasure to introduce today's distinguished resource person, Dr. Ratnakishore V. Sir. Sir completed his BTech in Mechanical Engineering from National Institute of Technology, Surathkal, and earned his MTech and PhD in Mechanical Engineering from IIT Delhi. His doctoral research involved experimental and computational investigations on laminar planes of multi-component gaseous fuel mixtures, highlighting his strong expertise in both experimental and simulation-based research. Currently, he is a professor in the Department of Mechanical Engineering, School of Engineering, Amrita Vishwavidyapeetham, Coimbatore. His research interests include aeroacoustics, computational fluid dynamics, combustion, microscale combustion, plume dispersion, and wind turbine analysis, with several publications in reputed international and journals and conferences. Sir has published 108 publications in premium journals and 4,000 plus citations too. In addition to his research excellence, Dr. Ratnakishore is a dedicated educator and mentor, guiding students and his researchers in developing strong analytical skills and effective scholarly writing practices. His insights to research storytelling and structuring impactful research papers will be extremely valuable to all participants of this FDP. We are sure that today's session will help us understand how to shape research narratives, improve clarity in academic writing, and enhance the overall quality and impact of scholarly publications. I now cordially invite Dr. Ratnakishore, sir, to take over the session. Sir, the session is yours. Thank you.
Thank you. So, should I switch on my camera? It's not essential.
Sir, it's your wish, sir. We can have the presentations, but if you wish to turn on your camera, you can do it. That's your wish, sir.
I think you have to unshare yourself. That is done. Okay, one second. Can you see my screen?
Yes, sir. It is visible, sir.
Can I know how many of you, everyone is from EC background or?
No,
No,
sir. We
sir, we
have
have
from
from
mixed
mixed
backgrounds,
backgrounds,
not just
not just
ECE,
ECE,
sir.
sir.
Anyway,
Anyway,
so
so
I
I
usually work
usually
with
work with
mechanical,
mechanical,
mostly
mostly
non-circuit branches. To some extent, I have
non-circuit.
done some work with EC triply, but not in respect to their work. It is more aligned to my research work, which I have helped someone in triply. So, okay. So what I'm planning to talk is about initial section is what is the content of any research work and how it has to be progressed. And I will show two case studies because some of you are not from mechanical or any non-secure branch orientation. You will not be very much interested, but at least it will help you to understand how a research problem would be formulated. And then I would get into more of how to write a publication. Fine. These are these 7 steps that are involved in any research process. This is a general categorization. Of course, they can vary. Some of the steps can be merged, depends on how you look at it. Okay. Am I audible well? I just want to confirm, that's all.
Yeah, it's fine.
Yes, sir. You're audible, sir.
If you have any questions, please raise your hand. I would not mind because at least it will be more interactive. Okay. So the first step is problem identification. This is the typical step that we ask most of my BTech students to do well, or anyone who does research. Okay. The second step would be doing a literature review. And third would be formulating the research question. Okay. Fourth would be the research design. And fifth is data collection. What you mean by data collection, it can be varying. Someone who's doing experiments would do experiments and collect data. Someone who does simulations like myself would do modeling and do simulations. And in certain fields, they will be mostly using survey. Generally, the people who do social sciences or anyone who do industrial engineering kind of research work. Case studies, surveys and case studies are more common for MBA, which is related to actual people. And based on the data that you collect, you do data analysis. The data analysis is quite big. That is what is called now data science. Okay. And then you interpret the data in a meaningful way, present it, and come out with a conclusion. Okay. The last step is reporting and publication. Okay. When I did PhD, the work used number of publications are very, very limited. Okay. And the purpose of doing PhD was to enhance teaching. I'm trying to say this statement because most of the time, even in my university, in several places now in the world, people think that research is just to publish. That mindset is not a very good idea. We do research so that we can teach well. That is a far better perspective to look at. Okay. And publication or reporting is done when you want to express something that you learned in the process of these first 7 steps to communicate to the world. So publications are not done just for the sake of publishing more and more. It is just to communicate to the world what you learned. Okay. That is the whole reason for writing a publication. Fine. With this as a basis, what is the research problem? Okay. So research problem, generally it is gap in a knowledge or a practical challenge or a theoretical inconsistency. So what do you mean by that? Gap in the knowledge can be that if you have questions, okay, in the topic of your interest, okay, that raises to gap in the knowledge. I will give you an example as I go on. Okay. Practical challenge is very reasonably a good thing to think about, because whenever you want to design something new, okay, you will encounter issues with the technical details of it that you want to. For example, I have been working on vertical axis wind turbine. Okay, one of the practical challenge which I am looking at is how to reduce vibration to the shaft of the turbine. Okay, because vertical axis wind turbine is less researched area in wind turbines when compared to horizontal axis. And I'm interested in vertical axis wind turbine, which can be for rooftop. Okay. So there are a lot of practical challenges in that particular design. So that leads to questions. Theoretical inconsistency, what we mean is, you always have, whenever someone does a theory for a given classical problem, it will always have assumptions. Or someone does experiments for a given hypothesis, it may not give you correct results. And when you remove those assumptions, it leads to more complex a problem. So these are the three ways to look at a research problem. So generally, when you start a research problem, you always look at the context and the background. Okay. So this is very important in sense that nowadays, can anyone tell me what is the big keyword in current research anywhere in the world? Sorry. I just want to know anyone, because there's so many people. I'm not boring.
Sir, AI, artificial intelligence.
AI, that's true. AI is not a, yes, it is a keyword for AI, but AI is not very useful to the practical world. In my opinion, AI makes people lazy. That it can vary from each person. That is true. But anyway, that is, yes. Okay. If you see on a practical scale, one of the biggest thing that is going on in the all over the universities around the world is sustainable development goals. Have you ever heard of it? Sustainable development goals. Okay. Of course, see, people speak about AI because it makes life easy for most of the people. That is how they look at it. But most of them are focused on sustainable development goals. So they want to have sustainability in life. So there are 13 sustainable development goals. Okay. SDG. Okay. So everyone wants to associate with that. So that becomes a context in the background. So if you are interested in something related to sustainable development goals, you look at that aspect, which all aspects of sustainability that you looking at, and then you work in the direction so that it is useful to the world. Okay. So the context in the background is very important in sense that it relates to the practical world, how it is useful. Okay. Then sometimes this context or background involves some sort of literature review, but that is not essential. When you start doing research, generally the context is given by the supervisor who's working with you. Okay. Then the next part of the research problem is problem statement. What I normally tell most of my students is that the problem statement, if you define it well, that sorts out half of the research. So the problem statement is, more you're clear about the problem statement, better is your work that is focused to. Okay. Because problem statement is generally the overall guideline of the work. Based on the problem statement, you do literature review, which gives the status of what is the research objectives that you're looking at. Okay. So once you have research objectives clear, you try to say why those research objectives will be beneficial to the world. Okay. So it can be that academically, it can be practically, whichever way, how it is useful. That is why I was using that statement. The study should link to sustainable engineering, innovation, and societal impact. Generally, in our university, they look at societal impact because whatever we do has to be useful to the world. So, based on that, you can get into specific questions. Okay. So, the last part is slightly different from research questions, is different from research objectives, because objectives are what we want to achieve. Research questions are how to achieve those objectives. Okay. So, importance of research problem. Okay. The main importance is that it gives you focus and direction that you have to work. Okay. Better you define your problem, it will be very clear how you want to achieve that. Okay. Second aspect is that it defines scope and boundary. What do you mean by that? Okay. So if I'm wanting to work on vertical axis wind turbine, which is my field of interest, okay, the main direction which I want to do is how to reduce vibration to the shaft. Because vertical axis wind turbine, each blade comes into contact with the wind only for a certain part of its revolution. Okay, so that leads to the force that comes onto the blade will go through a cycle. What we define that as ripple effect. Because of which the shaft will see a cyclic force. So you want to reduce that. So if I define the statement to reduce the ripple effect on the shaft, that gives me a proper direction to my work. Now, because I have defined that, I can get into more details, how to do that. What would lead to those reduction of vibration to the shaft? And what all I need to include without reducing the efficiency of the turbine. So these are questions that we raise will lead to better resolution of the question. How to approach it. When you are clear with the question that you are planning to work on, you will also look forward how to solve it. And 90% of the time when you are first time doing any research work, you should not get too much worried about the jargon that people use in any research publication. One will understand the jargon over a period of time. When you read a research paper, you only look at the abstract and the conclusion. And always understand with respect to layman language. It will help you to move forward well. Last part of the research problem, if you define well, will give you more practical relevance. And since we publish, it should have academic relevance. I'll explain you what is academic relevance. Steps to define the research problem. One of the most important steps is to conduct comprehensive literature review. Can anyone tell how you do a literature review? Some of you have already done your PhD. I'm not hearing any from anyone, so I really don't know whether everyone is in the meeting. Am I audible?
Yes, sir, you're audible, sir, actually. Participants,
You are audible, sir.
No, that is true. How do you perform a literature review?
We have to identify the key resources. We have to just went through the existing papers, journal and books.
That's true, but then okay.
Then we have to analyze and summarize the main point and identify what is the gap and what are the patterns.
Most of the time, if you're doing a literature review, you go through some of the databases. For example, the database most of us know is Google Scholar. How many of you have used it? Can you raise your hands? Okay. Google Scholar is like a guy which has which doesn't curate the work. Anyone who publishes, any publisher, whether he is a credible or not credible, can get their papers registered in Google Scholar. Okay, it is not curated. Curated in the sense that the publisher is not, even though he is not good, it can get into Google Scholar indices. Okay, so that is why it is not meant to be that great, but it is reasonable starting point. Okay, because most of the time we don't buy any of this better indexing systems. Okay, one of the better ones is Scopus. Okay, 1 second. So if you are looking at sorry, here's my if you are looking at Google Scholar or Scopus, how do you do literature review? Some issue that I want to explain this because this is the first step that is very, very important for people to look at. So, in both the cases, we first type keywords. If you see any of the journal papers, they'll give you keywords. Okay. For example, I have been working on ammonia hydrogen flames. This is a keyword. Ammonia hydrogen flames. Okay. When you type a keyword, you will get a lot of papers. In this case, there are 47,000. If the size number of publications are too huge, you have to refine it further. Okay. So, for example, I am working on hydrogen diffusion flames. Okay. So, when you type a keyword, and you're getting a publications. Now you see, the first paper is in a journal called Fuel. It is published in 2024. And this paper has been cited by 17 people. What it means is, all these 17 people found this work that has been published relevant to their research. So if you open these 17 people, these are the relevant work that has been done from 2024 to till date. Okay. That is how you look at any work that is done in the field. Example, you see this publication, Effect of Ammonia Substitution in Hydrogen Propagation and Emission. This is published in 2010. For this flame propagation of hydrogen flames with ammonia substitution, he has published something in 2010. And this has been cited by 270 people. That means there are 270 people who have worked relevant to this until now. So this is how you will actually start searching for publications relevant to your field. More you go through this list, at some point you'll observe that this list becomes repetitive. So I just want to share with you one of the review article which I liked over the years. Can you see my screen?
Yes, sir. Yes, sir.
Okay. It's a review article. Most of you can relate to this, okay, because it is used in daily life. Comprehensive review on thermal performance enhancement for domestic gas stoves. Of course, this is not very predominant in except Southeast Asia and China. Everywhere else, the gas stove is not so used a lot. Okay. When he wants to do a literature review for this, when he wants to publish, he has followed this methodology. He has used in some of the standard databases. Font size is too small, then please let me know. He has used some of the standard databases like Web of Science and Scopus, which are a broader database. Wiley, Springer, and Science Direct are publishing houses. Okay. He has used keywords like stove, cooker, cooktop, because sometimes in some countries, stove is called cooktop. So it varies from each place to place. Sorry. And he has used word burner, cooktop or burner. And he wants to include domestic gas. But he doesn't want to use word biomass, because biomass burner, he doesn't want to work with. Electric burner or electric gas or whatever it is, those a combination doesn't want. Induction and solar, these should not be there. Okay. When he entered these, okay, he ends up getting 1,633 articles from all these sources. Wiley, Springer, okay, Science Direct, Scopus, Okay. Out of which he has removed the duplicates. He ended up with 520. And this 520, he has looked at only abstract and title. That takes away another 386. 134, he has read abstracts. That removed again 41. Finally, he ended up with only 93 publications, which he read full text. Once he read full text, again, some of them he removed, 28. And in the final inclusion, he ended up with 67. So this is how you do a literature review. You start with keywords. You remove all the duplications if you are looking at multiple sources. Then you read only the title. You remove all the unnecessary work. Then you read the abstract. Because abstract is concise version of your complete publication. Then you look at the full text. Hope it is clear to you. Okay. Now, most of this process of first 2-3 steps, you have access to certain tools which will give you a better visual representation of the literature review. If you ever use that, they're available. I'm not going to teach that part right now. Second. So, if you conduct a comprehensive literature review, as I stated here, you will get very clear understanding of existing knowledge. What are the methodologies that are used for the existing knowledge to arrive at, and what are the gaps? This is one of the important steps to do any research work. Okay. Then, once you have looked at the existing literature, in some cases, if you are new to the field, you do not know how to understand the gaps. For example, I have been working in last 2 years, I have started working on battery modeling. I do not know what to work in the field of battery modeling. Whenever I go to any conference or for any workshop which is not relevant to battery modeling, even if I go for my own combustion field, in that institute, I keep meeting people who are relevant to battery modeling or battery design. Just to understand what are the problems they are looking at, how they are approaching, what all tools they use, how do they do experiments, whether there's a possibility to collaborate with them. Okay. This helps you to enhance your understanding of the research problem that is relevant to the current scenario. Then the third step is look at whether it is practical and societal impact is there. If the work is of a practical relevance, people appreciate the work because it is useful in some way. There's a lot of work that people do, theoretical stuff. Difficult to justify that work. Most of my research is relevant to fluid flow modeling, which has some practical relevance in some application or other. If you have done the first 3 steps, then you can narrow down what exactly you are going to work on. I'll slightly shift. This is one of the problem that I got in 2011. This is L&T switch gear box. We were asked to model the switch gear box to understand how to put the ventilation, the slots that you see here, so that the heat from the bus bars are effectively ventilated out. Okay. Can anyone tell what is the practical relevance of it? Hopefully, I'm not very boring.
No, sir.
No, sir.
So, switchgear box, generally what will happen, most of the electrical systems, whether conducting or non-conducting, there will be a dissipation because of the resistance that the substance has, where the flow is going through. You have to cool it down. So, because this problem is being solved by a BTech group, we wanted to look at whether any fundamental work can be done in this field. The first question that we asked ourselves is that what should be the opening? Where should be the opening? What should be the size? Can I understand it in terms of non-dimensional numbers? In fluid flow, we always do everything using non-dimensional numbers. So we ended up making a simplified problem of this, where the one that is in gray color is a heat source, is a bus bar. That is how you can name it. And we looked at vent locations in 4 configurations. It's a simple 2D where you have entry in the same side, that is, we named it as SS. Then there's an entry called diagonal side, that is B. Entry is from 1, the exit is from on top, exactly opposite. Then you have 2 in, 1 out, and 1 in, 2 out. Okay, so we always kept outlet on the top, because whenever there is a heat source in the bottom, the gas gets heated, it will raise up and it leaves from the top. This is what we learned from our school days. The land mass gets heated, the hot air moves up, and the cold air from this seaside will come towards as a breeze. Okay, so this is called natural convection. Okay, so once we formulated this question, so how did we formulate this? Because it is very relevant to this work, where we don't have the form of cooling in switch gear box is only using natural convection. So that is where we asked ourselves, is there any formulation that is available? Anyone has understood this problem well? So we started with the 2D problem. And then obviously when we do modeling, one of the first steps that we do to benchmark it with respect to existing results. Okay, and we did that. And we also do something called grid independence test. Because in CFD, computational fluid dynamics, we divide the physical domain. In our case, the physical domain is the air that is there in this region into small parts. You can see this. The physical domain is made into small parts, what we call as computational mesh. And What you see in red is my computational domain. So the outer 4 lines, or 3 in fact, 1, 2, 3, is the region where it is outside your enclosure. And you have 2 outlets on the top, 1 inlet in the bottom. Okay. So we have done the simulations. We have used a non-dimensional number called Rayleigh number. And we have done the simulations for different heights of your heat source. Okay. So when we did this parametric study, it gives us an idea. The parameters of interest is what is the mass flow rate and what is Nusselt number. Nusselt number, what it means is higher the Nusselt number, better is your heat transfer. So that is how you put it in layman language. Higher the mass flow rate, better is the cooling. So we did the simulations for different Rayleigh number. Rayleigh number is your non-dimensional number in natural convection. So because of that, we understood 2 inlets and 1 outlet is the best option for all the Rayleigh numbers. Okay. Then we moved to higher Rayleigh number, where the flow becomes more oscillatory, and we looked at that physics to understand whether the configuration of 2 in 1 out is same. Then we moved to actual 3D, where it looks like very close to a bus bar. 2D is like this. Okay, your bus bar is very long because it is elongated in 3rd direction, out of plane. But in 3D, you can actually model your bus bar as a cube. So after doing all this, we had a better understanding that heat transfer will improve when the number of inlets, okay, vent inlets are more in the bottom, okay, and you have sufficient vent outlets to the top so that the convection is, outlet should be much more than inlets. Okay. Okay. Sorry. Then the second problem that we solved 2 years back, which I think some of you can understand, is actually a cooling system. What you can see is the 3 plates which are cooling a electronic circuit that is placed on the top. It's a cooling plate for electronic circuit. So this is the work that we got from Bosch, okay, where they want to understand this turbulator that enhances the cooling. What should be the configuration? So in CFD simulations, we generally extract the region where the flow happens. That is what is represented as fluid volume here. And you see, this is what is the simulation that Bosch people have done, where they have done with a very large number of cells, 8.5 million. Okay. So, but the question is, does it have a generic answer? Because you can see these turbulators are, how do they look? They are looking zigzag. Okay. So we looked at the literature to understand whether this zigzag kind of turbulators are existing. The word that used is offset fin. Okay. That is what is the word, and we have done a detailed literature review. Understood that this offset fin turbulators which they are shown or which they are using in the industry, there is no correlation available between heat transfer and geometric parameters. Based on which we have formulated the question how heat transfer will get affected because of turbulators. Okay. So the turbulators have general geometric parameters are thickness, width, and height, and angle. For all these things, we have defined 3 non-dimensional parameters. And for these three essential non-dimensional parameters, we have done 3 levels of design points that leads to 27 data set. For these 27 data set of geometries, we have done simulations and I'm not going through all the details. Based on those simulations, we have generated a correlation. So that correlation, we have used data fitting. So you can see this is the predicted H value and this is the actual H value that we got in the simulation. So this heat transfer coefficient, when we make the correlation, that will be useful for a lot of people who are working with similar configuration. Okay. So can anyone tell what exactly you learned from these 2 case studies which I have showed?
Problem to be started with simple approach, then we can complicate that. First, understand the physics. First, we need to understand what is actually happening. Then we start with a simple calculations or simple approach. Then we'll keep on increasing the fidelity of the model. Then we can narrow the.
That's true. One way that is correct. So whenever we have a problem when you pose a research question, one need not solve the problem as a complex thing. It is always useful to decompose the problem as a simple, smaller questions posed and solve them to get a better understanding. Okay. So how to pose the question? As I said, research problem. Initially, if you don't understand how to state the research problem, it is always good to ask someone. There's nothing wrong in it. But if you are capable of reading literature, then it will help you to pose the problem. But never feel that the problem that people solve are complex. No. Any given problem that people solve are always easy. Underlying math will be extremely simple to look at. Fundamentals always remain same. Doesn't matter which problem that you're solving. Okay. So the last part of it, which I would come back to it, is how to write a scientific paper or a publication. Okay. One thing which I want to keep it clear is scientific paper or publication is the documentation. Okay. So now the question is, when you write a documentation, what is the most important thing that you have to keep it in mind? Anyone can state? What is the most important thing that you have to keep it in mind when you write a documentation?
The content should be true and not false.
That is ethical part. I'm right. I'm speaking about when you want to write a documentation. I'm not speaking about ethical part of it. When you're sitting and writing a documentation, you're typing something, you're documenting some work. What is that you have to keep it in mind?
Mental framework, sir. What are the things to be done? We need to have a kind of a structure.
most important thing when you write a documentation, you have to be clear with who are the audience. Okay. If my documentation is for a guy who is learning the subject first time, that documentation is called textbook. Okay. Because we don't assume anything, whether the candidate understands, student understands something. Of course, even to study a textbook, there is always a prerequisite. Okay. We don't ask LKG guy to read engineering book. That is why they do +2, they write engineering entrance test so that they have basic skill of math, physics, chemistry to come to engineering. So the documentation always keeps in mind who are the audience. When you write a thesis, a BTech thesis or an MTech thesis, the audience is either your supervisor or audience are the future generation of students who look at the thesis. So audience is something that you have to keep it in mind. So you cannot write the way you write a BTech or MTech thesis, you cannot write your journal publication same way. Because journal publication is read by a group of people who are already working in that field. What it means is, when you write to a group of people who are already working in that field, you start using technical jargon. We don't write lot of details. Okay. What do you mean by that? For example, I am doing simulations in Fluent. That is a software which I use, ANSYS Fluent. Okay. When I write a publication, I am not going to put a screenshot of which all steps I have followed in the simulation. I don't do that. I write it in a fashion that anyone who works in CFD or relevant field can read the paper and replicate my work. All the necessary details I'll give, but it is written in a concise form. Okay, we don't write step 1, step 2, step 3 to do the work or do the experiment. No, that is not the way it is written. But we'll write everything such a way that anyone who is in that field should be able to read and replicate my work. So the audience decide how you write. That is the bottom line. So any documentation, you have to look at what is the audience or who are the audience and how to write. If you look at some of the big publishers, for example, Nature or Science or any of the well-known publishers who have very large impact factor, they clearly demand that the number of figures in the publication should not exceed 8 or 10. And a researcher must have spent almost like 2.5 years of his research, but he has to present only 8 figures. Okay. So you should understand, it is catered to a very, very specific audience who are doing very specific work. Only those people will understand what he has written. So research publication requires, because it is going to a specific group of researchers in that field, you start learning the jargon used in that specific field. So when you do research, you don't have to learn jargon, because initially you learn based on the common language that you do. Layman language is fine. But when you are putting in terms of documentation, you start writing in terms of what people expect you to read. Okay, expect you to write, sorry. Okay, so the audience decide how you put the documentation in place. If you understand this, the word technical jargon that you're supposed to write in your publication, you have to know. And the tense, the format, everything will be known only by reading. That is the simple answer which I give to most of my students. If you want to write a publication, you need not be very great genius, but you should be very sincere in reading papers multiple times. Okay. The bottom line of if you give a statement that I read a paper is that you should be able to speak on that publication for at least half an hour, not 15 minutes. That is the detail in which you read a publication. Okay. So the general demands for a publication is to have a clear logic, clarity, and precision. Okay. So this is not essential. The typical paper has these categories. You have a title, authors, abstract, and you have the main body will have an introduction. The introduction will give what is the need for the work. Then you have a development based on what you are working on. The final part of the work would be conclusion and acknowledgements and references. Okay. As I said, if you want to write a publication, the only way to write a publication is write and read what you have written and look at it whether what you have written is understandable to others, and edit it such a way that it is you are expressing what you want to convey to others in clarity. So the first word, clarity, is the most important thing. Logic is anywhere there, but the clarity. Okay, so how clearly you communicate things is the most important part. Okay, so the rule of scientific writing nowadays is never use a sentence which is very long. You always have to make sentences short. Okay, because it is not like a classical English literature where you have two subjects, two objects. Okay, it will be connected multiple ways. It's very difficult to write. No, that is not the way it is written. Writing is always done with shorter sentences and conveying a simple thing that you are trying to convey in a very short way. Sorry. Long sentences, no. You always should use shorter verbs. Do not use adjectives and all these complex English things. Okay, so there are a lot of places in literature, if you see, some journals accept active construction, but there are places most of the time in my field, the sentence formation is always passive construction. Title. You can start with the title, but title should be such a way that it is helpful for people to understand what you have worked on. At the same time, it should be catchy and someone can remember. Title should not be too big. Yeah. But it should not be like 3 lines. I have seen someone making a title which is 3 lines. Generally, title will not be more than 10, 15 words. It's very rare. Okay. Abstract is written typically 200 words, not more than that. But abstract is usually written at the end. The general construction of abstract would be that first line would be a kind of introduction or importance of the work. Then you have 2-3 lines about the methodology and what you have worked on. And last 2-3 lines will be typically the conclusion, the main conclusion or the output of the work in simple terms. We don't use enormously technical jargon, reasonably, but it is abstract should be easier to understand for anyone who reads for the first time. Okay. So you should remember the most often people read abstract, because that is where whether they are interested to look at your work is based on only reading the abstract. Okay. I'll come back to this. Okay, fine. When you write introduction, okay, this is the first statement which I liked a lot when I read this. Often the first paragraph, the first sentence that you write attracts people the way whether they are interested to look at your work. Okay. So the first paragraph of your introduction always starts with why I should actually look at this particular problem that you're working on. Okay. So introduction is not too long. Anyone would like to look at a paper and show you how I have written introduction? Please raise your hands. If it is too boring, then I'll do that. Fine. Thank you. I'll go back to the same problem which I've worked previously. So numerical study of effect of vent locations on natural convection in an enclosure with an internal heat source. If you look at the title, the word numerical study will tell that whether it is experimental or numerical, that is. And what I looked at is vent location. What is the phenomena? It is natural convection. What exactly is natural convection? That is listed out in the last line. Okay. So when anyone who's interested in understanding such phenomena, it is very clear in the statement. Okay. And if you look at the abstract, the first statement speaks about where it is useful. Okay. So it is useful in cooling of large scale electrical and electronic equipments. The word large scale is primarily used because we started this work with switchgear. Okay. Then what is the current work that we have done? So the current study involves effect of, again, the just broader explanation of what the work is and what all aspects that we looked at. We looked at 2 different aspect ratios, that is width to height of your heat source and 3 Rayleigh number. And which all configurations that we worked on, the 4 configurations. Then the last 3 statements speaks about what is the analysis and what are the main conclusions. So you can see the main conclusion is 2 in 1 out is the best configuration, and flow rates and Nusselt number increases. Okay, with increase in Rayleigh number, decrease in aspect ratio. So if you see, the abstract is very simple. It tells me very clearly why this problem, what I worked, what I did analysis, and what is the main conclusion of the work. Just by reading this 120, typically 200 words, anyone can understand what this work is about. Okay. So then, based on this work, we list out certain keywords. Keywords are more natural because you see that we worked on natural convection, we looked at enclosure, we are using non-dimensional numbers, which is called Rayleigh number in our case, and vent position. Okay, so typically the keywords are what, if someone types on Google Scholar or any other place, keywords are the first thing that they search to see whether this work is relevant in the search or not. So when we write literature review, the first paragraph speaks about why should I work on this? Okay, so the first line, the way we wrote was, heat generation cannot be avoided in day-to-day life. Okay, so it is essential to remove this heat that is generated in electrical and electronic appliances. So the statement is about where it is useful. Okay, so electrical cooling. Then, based on that, we explain what is the study and how it will be helpful for people. The first paragraph is always introduction about why this work is so essential for people, practical relevance of it. Then, because I'm trying to look at natural convection in an enclosure, we do all the literature review that is relevant to natural convection. We started with the oldest work, and then we looked at all the different people who have worked on natural convection. Okay, and came to a conclusion that no one has worked on natural convection with heat source. Okay. So the last paragraph of your literature review tells the novelty of the work. Generally, any reviewer who reads a paper would read this paragraph to tell whether the work is novel, how it is different from others. Okay. Then we wrote a problem definition to the detail. What is this different 4 configurations, how we chose different heights, and then we wrote mathematical model. So we are not writing how to use it in Fluent, how to click, how to use GUI, that is not written. It is written in technical jargon so that everyone who works in that field understands it. Okay. So then we wrote other details of the work, how we have done meshing, and what all boundary conditions that we had, so that anyone who works in this field knows that how to replicate this work. Okay. Finally, we come to results and discussion. Now, results and discussion can be expressed in several ways. Every field will have a different ways of presenting the results and discussion. But the clarity of presenting of results and discussion makes your publication better, and the analysis that you do. In our case, we are trying to do analysis of results and discussion in terms of streamlines and isotherms to understand where are the dead zones. For example, here there is a big dead zone that you see as a recirculation, and we are trying to see that more these dead zones are, less is the heat transfer. Okay. So we started explaining those dead zones, the reason of those dead zones, why it got reduced, and all that phenomena. And we presented the data in terms of mass flow rate for 4 different configurations. Okay. So never get too much. If you observe the publication, you will know that how they have presented a figure. Okay. So generally, when you make an Excel sheet, you'll always have a heading, because that is for making in a PPT. Any general publication, they never have a heading. Okay. And these figures, you need not have a very complex software. If you ever use an open source, one of the best source that is available is either to use something called gnuplot, okay, which is a very free software, which can take, okay, fine. It is an open source. which can make a very good figures, 2D and 3D, if you ever want to use. Initially, I used to use a software called Sigma Plot, which is commercial, but nowadays I'm using Blueplot. This is free to use. Okay. Or you can use nowadays Python, Matplotlib. Okay. Any of these free softwares will give you very good quality figures. Then finally, when you write entire presentation of your work, the summary conclusion of your work, you present it as conclusions. So if I'm writing a publication, essentially in my field, I would always ask my students to present it as a PPT and present all the work so that they explain the nature of the work, hypothesis, how they approached, what they have done, and look at whether there's a significant contribution which I want to share with the world. And based on that, I derive the conclusions. And to substantiate those conclusions, I start writing my main results and discussion. That is how I work. Okay. Fine. I think because it is, some of you may not have worked in my field, so it will be a little boring to you. I would take questions first. Anyone has questions?
Sir, good evening, sir.
Yes, please.
Sir, can we include some data, some results, some values in the results in the abstract, sir? For example, some hardness value or something. Can we include that? So those values in the abstract itself.
See, when you write abstract is a shorter version of your paper. We don't get into details. Okay. See, because abstract is hardly 200 words. No one accepts more than 200 words. Okay. Yes, there are places that they do write values, but it's very rare. Okay, because you hardly get 12 maximum 10 sentences you get. Okay. If you finish like 5-6 sentences on what is the object of the work and what you are going to do in this work, that takes away first 5 sentences. You are writing only last 2-3 sentences about the conclusion of your work. And very rarely people write actual results in it. We always write how better is my work with respect to the previous literature, how much it has improved, the major outcome of the work, 1 or 2 lines you write. So we don't get into actual details of the work, the abstract.
Okay, sir. Okay, thank you, sir.
Sir, I always get a confusion when after the introduction we always give the methods, then the results. When we are discussing the methods and results, I always have a contradictory, because when we are discussing results, that time some of the lines which I write, it will go to the methods. So it keeps on repeating. I always get a confusion, sir, on that.
Okay. See, the general way of writing is you write methods, you only describe the methodology of your work. For example, you are doing work on the acoustics, right? Source prediction and things like
Yes,
that.
sir. Yes,
Yeah.
sir. Yes, sir.
So you only write about algorithm that you're using, why you're choosing the algorithm, why it is better than others, okay, choice of algorithm with respect to literature, okay, where all this algorithm has been used, okay, and the mathematical formulation of that algorithm, okay, or the methodology that you're using. Those are written in methods. Okay. And the application of that algorithm, whatever results that you get, or whatever data curing that you're doing based on those methods, those are presented in results.
Okay. Okay. When we are describing the results, that time the methodology can be quoted, or is it the?
Yes, you can quote.
Okay.
Because see, if you want to make the readers clear, okay, for example, you are doing, in my case, if I'm doing an average Nusselt number, I can always quote that this calculation has been done using this formula that is there in the previous section.
Okay. Okay, sir. Thank you, sir. Thanks a lot, sir.
Any other questions?
Participants may raise your hands if you have any queries. I think we can continue, sir.
Hello, sir.
Because anyway, time is very short. I would conclude it. If you have any questions, then I'll clarify, or else I'll not get into more details. Someone was asking questions. Sorry, I stopped.
Sir, what you
Sorry, your voice is cutting.
Sir, what exactly does a review paper intend to convey, sir?
The main purpose of a review article is to see what is the current status of the topic that you're looking at in detail. Okay. And nowadays, review article is written by anyone and everyone. Okay. At least 5-6 years back, a review article is written. If you want to write a review article, you are supposed to write to an editor saying that I want to write a review article, and you have to show the sufficient proof to the editor that you have worked in this field for sufficiently long time. Okay. Because the purpose of writing a review article is to write what is the existing work that has been done, and comprehensively you create the work to generalize the status clearly and give a guideline for what is the future directions for the research. Okay, so that can be done by someone who has already worked in the specific field for at least for 5 to 7 years. Okay. But what I see nowadays is that anyone writes a review article without even working in that field. And that doesn't give you a good review article. They write something based on literature, but it will not be effective.
Okay, sir.
For me, time is a little short, so I could not express more details about publication, how it is written. But any one of the participant would like to speak to me in person, there is no issue. But I can only express in terms of my field because that is easy for me. I've never worked in relevant to circuit branches. Their nature of work is slightly different from ours. Okay. I can understand work that is relevant to chemical, mechanical, aerospace to great extent.
Sir, one last question, sir. Actually, we keep on writing paper. Every time we read, every time once it is read, we feel that there's something to be modified, something to be modified. It keeps on increasing.
See, that is true. See, when you read your article, you'll always feel that it is not perfect.
Yes,
it is understandable when you're writing for the first time. Okay. It's an understandable anxiety. Okay. But what you have to keep it in mind is when you do research, you cannot make it everything perfect in first go. But underlying factor that you have to look at is, am I able to communicate what I have done so that anyone who reads in the similar technical background, will he be able to repeat or replicate my work? Okay. So, see, for example, you are using MATLAB.
Yes, sir.
For
algorithm development as well as
algorithm or whatever way it is. Okay?
Calculations, yes, sir.
Calculations. But you are not going to say that this is my program, this is how I have given input, this is what I got output. That is not what you're going to write.
Yes.
Okay. As you express what is your input, but you're not going to state all your input data. In last 1 year, it's very clearly asked by every publisher that please share your input data and output data in an open domain so that availability of data is there for everyone. Okay. So that has become a common practice with most of the publishers.
Okay.
So they expect you to put up your data, but you have to express what are the algorithms that you're using, which software that you have used, what all you have inputted in a specific way, so that anyone who reads your paper should be able to solve it. Okay. As long as that is satisfied, you should not worry about the language. Of course, you also have to look at the clarity of presentation. That is what I said. It's a given statement because anyone who wants to use your work, there should be a clarity. Okay. So that is why the structure of your presentation should be proper. Because you are speaking about results without specifying how you have done, then people cannot understand.
Okay, sir. Thank you, sir. Okay. Yes. Thank you, sir. Yes.
Any other questions? I don't know how useful it is for people, but then time is a little short for me to express everything that I work on, writing about publication.
It's very useful, sir. It's very, very much useful. Thank you.
Any participants, those who have any question may please raise your hands.
Anyway, so since no more questions are coming, I can only tell you that many times you are asking whether it is boring and how is it and things like that. I think it has been extremely useful the way you have conveyed it, and I think most of them will take it very well. Too many questions and things like that are not coming as there aren't too many of them who are in the process. Many of them are thinking of joining and doing research and things like that. So it is in the preliminary stage. So that would be the reason.
That is okay, sir. See, it's understandable.
Yeah.
Okay. See, to me, it is not essential for everyone to do research. Okay.
Yeah.
But it is helpful to read some publications because it enhances teaching. For me, the bottom line is teaching. You do research to teach well.
Correct. So our attempt is also that once they read more and once they write more papers, their general output and will be better and their quality of life will change. It is for their own growth. So it's a slow process. So your day, you really made a very nice thing, and I'm sure that would be the view of everybody else. Thank you so much. Thanks.
Okay. Thank you. See you. Have a nice day.
Thank you, sir.
Bye.
Thank you.
Okay, sir. So, thank you, sir. I'm Anjana, and on behalf of Vidya Academy of Science and Technology, Department of Electronics and
you, sir.
Communication Engineering. So that brings us to the end of today's session. On behalf of the organizing committee, I extend our sincere thanks to Dr. Ratna Kishore, sir, for a highly insightful and enriching session. We truly appreciate your time and valuable guidance, sir. Thank you all, dear participants, for your active presence today and your engagement too. And we look forward to meeting you again tomorrow at the same time, 7 p.m. for the next session of this FDP. Thank you all and have a pleasant evening. Thank you so much, sir. This was a really very informative session for many of us who are pursuing our PhDs now. Thank you so much, sir, once again on behalf of the organizing committee. Thank you, sir.